We're going to do more problems on substitution reactions, choosing the reagent to accomplish a given transformation. So this time, let's do what is the structure that we want as, say, the substrate that we want to transform. And I have this, and I need to figure out what goes in the arrow. So what is the reagent that we need to use? And my target molecule, so the product is this. So I see that I have replaced the OH by bromine. Notice now what is the structure of the alcohol here. The alcohol, here's where the OH is. This is my alpha carbon, and it has 1, 2, 3 alkyl groups. So this is a tertiary alcohol. The reaction is a substitution. We are changing the OH by bromine. Tertiary substrates tend to react via SN1 reactions. Now, via SN1, this reaction proceeds stepwise through a carbon-cation intermediate. So now we know intermediate. We know that OH is a bad leaving group. So how do we make it a better leaving group? In the previous example, under basic conditions, we transform that into a tosylate. Now, under acidic conditions, there is another way of removing the OH, which is what we will do here. So under acidic conditions, say that I have an acid that will be the source of protons. So now that we have an acid-base reaction, proton transfer, and we're going to protonate the alcohol. What I get now, this is my protonated alcohol, and I have an excellent leaving group. So this water is going to depart, and you're going to have an intermediate. That's a carbon-cation. And we know that that's tertiary. So I already transformed that again into a better leaving group. Next step, you need a nucleophilic attack. So you need bromide, because in that reaction, you're replacing the OH by bromide. And it will attack over to the carbon-cation. So proton transfer, nucleophilic attack. At the end of the day, you need a source of protons, you need a nucleophile. So the answer to this problem, we need HBr. So this is the reagent that we're going to put here. So you need reagent A, which HBr. Okay? So we were looking again at a structure. It is tertiary, so we know that substitution, the pathway is SN1 through carbon-cation formation. Let's do one more problem. Again, choosing the reagent. I'm keeping the same list. And we're going to do another reaction to select the reagent. Okay, here we go. Now the reaction is the following. I have the substrate. This is an alkyl halide, 1, 2, 3, 4 carbons, so 2-chlorobutane. And it's changing. So this is my target. Notice a couple of things here. Let's analyze the structure. Here, where the chlorine is my alpha carbon. And it has attached one alkyl group and another alkyl group. So that is a secondary alkyl halide. So secondary substrates can react sometimes SN2 or SN1. But we see here that we have replaced the chlorine by SH, but there is inversion of configuration. In other words, here you have configuration here is, say, priority 1 is chlorine, then ethyl, then the methyl hydrogen is in the back, so this is S. It changes to R absolute configuration. The mechanism that does that, it is this mechanism is SN2 in which we have concerted nucleophilic attack and loss of leaving group. What do we need to do here? Where we do have a good leaving group, so let's see now what can do that reaction. So good leaving group, and typically we need good nucleophiles. We use good nucleophiles, strong nucleophiles. Here, in this case, the appropriate reagent is F. So you have HS negative. Remember that sulfur is right below oxygen in the periodic table. So similar, but larger orbitals, so it's much better nucleophile. So you will have the nucleophilic attack. Let me erase that just to show the lone pairs. Let's remove that. So 1, 2, 3, 4, 5, 6. And here you will have the attack from the back side. And you get the product with inversion configuration. So this is the appropriate reagent to do that reaction.